Okay, so today for ellipses, again, I did draw a giant ellipse all over the definition here, but it's just a set of points whose distances from two fixed points called the foci is a constant sum. So I had a volunteer put his fingers here, and I used a loop to draw this. As you can see, my loop was way too big and it wasn't our best work, but this was what an ellipse would look like. You might figure out, what do you think would happen if these two focus points, as they keep getting further apart? What would it do to the shape? It kind of stretches it out, makes it a lot wider, correct? And not as tall. What if the focal points or the foci get closer together? It gets more like circle-ish, right? What do you think if the focal points are on top of each other? It is a circle, right? So the measurement of how circly it is compared to how out of circle it is called eccentricity. And if you study a lot of ellipses, you might look at the eccentricities. Like if you look at planetary orbits, they have different eccentricities because some of them are more out of circle than others. Planets follow an elliptical path, right? With the center of mass of the heaviest object being one focal point, and then the center of mass of the system being the other focal point. So kind of, it's one of the first places this idea kind of came up, or people started to study it. So let's look at the equations behind this. And before we leave though, this focal constant that we get here, if you think that length, now we know this would be our major axis, correct? It's the longest axis. This focal constant, this length, plus this length, is just the length of the major axis. So if you think about it, take this piece and lay it to the left. If you take this length, it'll go between these. It'll also have this same length over here. Right, so that's where we can get that focal constant if we need it. It is the same as the major axis. Okay, so for our formulas here, to fill out your note sheet, is we're going to break these into two types. The types that are wider, right, bigger side to side, and the ones that are taller. They have some differences. So in this case, we're going to say that a squared is greater than b squared, and we'll see where those fit into the equation. But in general, remember, a's are always going to go with the x value, and b's are always going to go with the y's. So our form here, our equation, is x squared over a squared plus y squared over b squared equals 1. Okay, so this is our standard form, is x squared over a squared plus y squared over b squared equals 1. Again, remember, x is always going to stick with the a's, and the y's are going to stick with the b's. The next thing we want to look at are our vertices. Now I'm going to include the vertices and the co-vertices here. But the vertices, in the x direction, we're going to use a to find those. So we're going to get a0, negative a0. Those would be your two vertices. And then those would be your points out here. And then we're going to have 0b and 0, negative b. Sometimes you'll call those co-vertices, but sometimes you just call them vertices also. And that's going to be up b units and down b units from the center. Right, so we're all moving from the center here. The major axis is the longer one, so it's going to be horizontal in this case. And it's going to have a length of 2a. And then our minor axis is going to be vertical. And it's going to have a length of 2b. And then the last thing we need to determine, which we really haven't talked about, we'll need a formula for this, is where are the foci. So in this case, the foci, now I always think of these are going to be c units from the center. So maybe I'll write this up here. So these are always more than just a formula. Plus or minus c units from the center along the major axis. Okay, so in this case, because a squared is bigger, to find c, we're going to do c squared is equal to a squared minus b squared. So what you'll do is you'll find the difference of those two denominators every time, and that will give you c squared. So in this case, the foci will be c0, negative c0. And they're going to be on the major axis inside of the vertices. Okay, so that's, again, c squared is going to be a squared minus b squared in this case. It's always got to be a positive number, though, because you're going to square root it. So you'll see the other case in a second here. Any questions with this? So again, the a and b part we kind of had from the first part of our, kind of working through some things. So let's look at the other case we have. In this case, it's not my best work, but it's still a ellipse, kind of. But this is going to be one that's taller. Right? So for this one, the form, we're going to use the same form of the equation, but this time b squared, well, let's maybe be consistent. So we're going to say a squared is less than b squared. Right, so here the denominator underneath the y is larger. It's larger for us. So our vertices would be at 0b and 0, negative b. Right, b units up, b units down. Again, b squared is the thing under the y squared. And then our co-vertices would be a0, negative a0. So again, those all work the same way, correct? Just you ended up going further up than you did side to side. So then our major axis would be vertical, and it would have a length of 2b. And then the minor axis would be horizontal, and it would have a length of 2a. Right, so the lengths are the same for side to side and up and down. It's just you change which one's called the major and which one's called the minor. The foci, this time, it's still going to be c units from the center, but this time it's going to be on the major axis, which is up and down. So it's going to be the point 0c and 0, negative c. And in this case, c squared would be b squared minus a squared. Right, we take the longest denominator and subtract the smallest denominator. So if you want to, go ahead and make sure you have those down, and then let's just try to identify the pieces on this picture on our note sheet right above this, and we'll go through that together. Okay, so here's our first kind of sample here. We're given this graph. And our goal is to write the equation for the ellipse, but I would probably recommend that we maybe fill in some of this other pieces first. And we're also going to try to find where the foci are at. So, well, the first thing I realized is kind of my standard equation we said is x squared over a squared plus y squared over b squared equals 1. Okay, that's if the center is at 0. Does it appear the center is 0? Yeah, it goes from negative 3 to 3. And then negative 7 to negative 7, so yes. So we could say safely that our center is at the origin at 0, 0. So we're going to keep it that way today. Vertices, the vertices on the major axis, are kind of the more important ones I would guess, are at 0, 7 and 0, negative 7. You will see people write 0 plus or minus 7. That's nothing wrong with that. And then at 3, 0, and negative 3, 0. So those are the co-vertices. Now, the major axis, we know it's going to be the longer one, right? And that's going to be the vertical. And it's going to have a length of 14. And then the major is going to be horizontal. Or I'm sorry, the minor is horizontal, and it has a length of 6. Are we doing okay? So at this point, can we write an equation? Sure. So whatever 3 is going to be the number that is a is going to be 3 or negative 3, correct? So we can say x squared over 9 plus y squared over 7 squared, which is 49, equals 1. Now, just to find the foci now, c squared is going to be the difference between these two numbers. So we could say that c squared is going to be 49 minus 9. So c squared is 40. Square root c is plus or minus radical 40, which is plus or minus 2 radical 10, which, now we just need to approximate that on the graph. It's kind of hard, especially to see. 2 radical 10 is the nice number when you rationalize it. But actually, radical 40 is easier to figure out where it's at, because we know the square root of 36 is 6, and we know the square root of 49 is 7, correct? So it's somewhere between 6 and 7. So up here, I'm going to just put a point and put f sub 1, put f sub 2. Doesn't matter which one you call 1 and which one you call 2. So our foci would be 0, 2 radical 10, and 0, negative 2 radical 10. Okay, so our next example here is we're asked to graph this function 16x squared plus 9y squared equals 144. Now with this is not in the right form, right? If you think back to our forms, both of them had x squared over a squared plus y squared over b squared equals 1, right? So the big thing we need to have is this to equal 1. That's kind of the driving force of how we're going to change this equation. So, 2 ways to do that. You could subtract 143 from both sides. Don't do that. It doesn't help you at all. You'll still get 1 on the right. But the better way, the way we need to do it, is we're going to divide both sides of the equation by 144. And when we do that, we'll get 16x squared over 144 plus 9y squared over 144 is 144 divided by 144. And then at this point, we can simplify, and we get x squared over 9 plus y squared over 16 equals 1. So that's actually the equation that we want to graph right there. So part of this deal sometimes is you're going to have an equation where you have to modify it to get it into a form that you're familiar with. So this is like the other ones we've seen today. There's no numbers up with the x and the y and a parenthesis that would indicate a movement of the center. So our center is going to be at 0, 0. You can put a point there if you want. Kind of optional, I would guess. Now the vertices, the 9 underneath the x squared tells us we're going to move the square root of 9, or 3 units from side to side, from the center, correct? So we'll start at the center. We'll go 3 to the right, go 3 to the left. So those would actually be our co-vertices, would be 3, 0, and negative 3, 0. And then the 16 underneath the y squared tells us that we're going to do the square root of 16, or 4 units up and down. So up 4, down 4. So 0, 4, 0, negative 4. Now at this point, I guess my scale is not great there, but at this point we have enough to draw the ellipse, correct? It looks more like a potato than an ellipse, but we could make a Mr. Potato Head ellipse package or something, I don't know. But we just want to find the points for the foci. So what we need to do is c squared will be 16 minus 9. So that's 7. So the foci are radical 7 units on the major axis, right? So that's going to be up radical 7, which is a little bit less than 3. And then down radical 7, which is a little bit less than negative 3. And so that's going to give us 0 radical 7, 0 negative radical 7. If you ever wanted to, you could take any point here on this picture, and it should always be the same. What would it be? It would be 8. Any point, if you did F1 to this point, P, if you did this length plus this length, it should give you 8, which is the length of the major axis. Right? We didn't actually say that. So the major axis would be vertical. It has a length of 8. The minor axis would be horizontal, and it would have a length of 6. Is that working for us there? Any questions? Okay, so I would say let's just go ahead and work through the rest of the packet then.